Well, hi, and welcome to Jim's Radio Shop, where I'm continuing work on the Philco 91A chassis you see here. And I'm going to be reinstalling this coil after rewinding it here. And most recently coating the windings. So, as I've mentioned, my video camera likes to stop for no known reason. And since I'm not always observing the screen of the camera while I'm working, sometimes I miss the fact that it stopped. And of course, I don't know when it stopped, and so I apologize for that. But in any case, I took the opportunity to watch back one of my videos and verify where the various wires are going in here. So this guy goes here, this guy goes here, there's one up here. It's going to be a little bit of a problem because it broke, and this guy goes here, and this capacitor goes here. Did you follow all that? So I make one connection at a time, and slowly put this guy in. So this one goes here. Yeah, like any problem, this might seem a little overwhelming at first. For instance, reconnecting these wires correctly struck me as, to make absolutely sure you've got them right, it's a little bit of a problem. But if you just kind of do one at a time and sort of break the problem down into smaller pieces, one wire at a time, you might find that, well, the 4 wires, there's no doubt where 3 of them go, and then the last one obviously goes where it has to go. Sometimes problems solve themselves. Is that true? Do problems solve themselves? That sounds like a anti-Murphy law there, that's for sure. So we'll solder this guy in first. There he goes. And I think we'll do this guy next. That's 2 done. Now let's attend to the difficult one. It's a wire that comes from here under this block and connects here. It's a straight wire, and when I disconnected, the very end of the wire just broke right off, and now it's too short. So that's no good. So I got to put a new wire in from here down to here. I think that's the only logical thing. There's nothing else I can do here. So let's get this wire out. I don't want to flex this resistor. It's easier if I just get a hold of it here. And see if I can't desolder it and kind of wiggle it off. Come on, little guy, you can come on. I didn't like that approach. If I tallied up all the hours I spent with this particular pair of pliers in my hands. There it is. There's the bad guy with the broken end. I'm just going to use this wire cut a piece off. Let's see, should I make the same mistake with the, like I did with the string on the PT10, cut it unnecessarily short, providing myself self-induced headaches? No, let's make sure it's long enough. There we go. Where to connect first? Let's connect it at the top first. We'll shape this ahead of time. Try to fish it down behind there. It's a pretty stiff wire, but okay. There we are. Oh, I made it really long. Too long. And it fell right through. Yeah, let's shorten it up because it's too long. I made that wire short and straight maybe for a good reason, so you better follow right along. Okay, hoping I haven't cut it too short now. Down you go. Okay. Now the insulation has traveled on the wire a little bit. Let's see if we can pull it down. There we go. Oop. Hey, wait a minute. Don't disappear on me now. Hey, it snuck out. That's a tricky wire. I thought I was smarter than a piece of wire. Maybe not. Keeps getting caught on the lip of the can. Dun, 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 dun. Perfect. Okay, let's hit that with solder. That looks perfect. And now we'll get this wire to reach the coil lug here. I think that's fine the way it is. Let's solder that. Yeah, looks good. Other solder joints look good. We'll attach, this is the high voltage wire. Good. Solder that. Hey, I might be trying this set out pretty soon. Now, this is the set that fooled me a little bit. Not that it's that tough to fool me, because it worked partially, even with this coil defective. So I now have 4 wires connected to the 4 lugs. I haven't forgotten anything. Push that down close to the chassis. Kind of curious about what happened in here. That's not me. The last guy is this guy. He goes back on here. I bent him a fair number of times, so I don't want to bend it too many more. Oh. There we are. Getting a little excited here. Look at that. Looks good. Now, should we do something about this resistor? The stock answer would be yeah. At the very least, we should check it. Look at it, it's all cracked. It's an old dog bone. Looks like brown, green, orange. Body and dots. I suppose the cracked porcelain cover doesn't mean it's necessarily bad. It's connected to this other coil. I think we can spot that on the schematic. Hey, first we have to spot the schematic. There we are. Okay, so that's the coil I just put in. The next one in line is back here. There's a resistor right there coming off what I would believe would be the secondary side of it. So there's no resistor on the primary. So there's only one resistor connected to any way to that coil. That's number, what is that, 26? Number 26. So can we find out what 26 is? Number 26, red, black, green. Well, it doesn't look like red, black, green to me at all. what else? There's a terminal there with solder on it. There's no wire connected to it. A little odd. What would that be? So that guy this diagram's not helping me too much here. So this is the block here. Looks like it says 21 pointing at something right in this area. It could be a capacitor. There's a number there pointing also. What's that number? 20 20 blob. I can't. It could be 20. It could be 20. Let's see. 20 is a condenser. Brown, black, orange resistor. Compensating. There's resistor. Red. 24. Red, black, red. No, it's brown, green, orange. Where did they find that? Show me a brown. I'm just looking down the list now. Brown, green, orange. Brown, green, orange. Brown, black, orange. Brown, black, orange. Brown, green, orange. Well, it could be a replacement, and it's not an exact match. This might not be correct either. Brown, black, orange. So that'd be close. That's resistor number 21. Let's see if I can find that up here in this diagram. There's 21. You know what? It's pointing right into the right area. 21 points right there. Okay, now there's another one. There's another resistor here. This one is red, black, green. That's different. So it looks like it's resistor 21. Brown, black, orange. So that would be, if it's a brown, black, orange, then that's 10K. That's pretty easy. 10K. Let's measure it. Let's see what we get. $13K. 13K. Let's see. 13K would be a brown. Well, it's pretty close, isn't it? Brown, green, orange. I think that would be 16K, and I'm reading 13.2. I think I'm going to leave that guy right there, even though he's cracked. Unless we have some reason to believe we need to change it, we better not. I think we're ready to turn this guy on and see what effect that coil had. Yeah, let me just get the speakers. Okay, so I have the two speakers plugged in. Once again, you can see the terrible condition of the coins on these things. They're just, look at that, it's just terrible. So just plug them in there. That's the plug. Yeah. But I almost forgot to do one thing, and that's reconnect the grid cap. So we're gonna lay this guy down. It's a heavy guy. Okay, there's our wire. Here's our cap. Now, just going to set it loosely on top there. Certainly don't want to heat up the tube too much here. Go. Not so neat looking, but I think that's secure. Let's check it. Yeah, it is, but we got a few strands here that are wandering around. So. Not pretty, but enough to do the job. Yeah. Down she goes. Okay. I think we're ready. Ah, this radio is really taking a mud bath. These tubes are just filthy. But why don't we extend out the antenna here? Word here. Right tool for the job here. Okay, so that's the tone control. That sounds like an on-off switch, doesn't it? That's what it must be. There's no bands on this thing. It's just an AM radio. We're ready to go. We are ready to try this guy out. And I've had him operating a couple of times already, so I'm not too worried about it. Okay. Quick little Safety check and make sure nothing stupid is going on. Okay, so we're gonna apply limited power first. There we go. I'm sure you can see that light. Come on there. Our voltage is around 80%. I think you can just see these bulbs here. Oh, yeah. That's my current limiting bulbs. The volume is down. So it might take a little while to warm up when the voltage is restricted, because we're running around 80% of line voltage. So we're down around 90 volts here. I can see the tube heaters coming on. Both my fingers crossed. You can see the line voltage, supply voltage dropping a bit. That means the current is picking up and the set plate current's flowing. Let's just give it a little bit of volume here. Oh. Well, isn't that a disappointing result? Now, what am I doing wrong here? There's not much to do with this radio, so... Well, you can definitely hear the tone control working. Working very well, in fact. Okay, so we know the audio side of this radio appears to be working quite well. Still getting nothing happening here. Oh, the disappointment. Yeah. Okay, I had another one of those camera stops. So again, I don't know how much I missed, but I'm gonna... Uh-oh, we're seeing smoke. We're seeing smoke. Smoke, smoke, smoke. Smoke coming from something. Smoke's coming out of here. We got something burning. We got fire. We got flames coming up out of that. Ooh, that's not good at all. Let's take a look and see what do we cook. Lovely aroma in my shop here. What's cut? Oh, way down in here. Weird, it came out of a hole up here. $34. Oh, it's a coil. Yikes. It's just the last thing you want to do is cook a coil. It appeared to be the case. Guy's pretty warm. Well, doesn't that make sense then? You have too high a current going through here, overheating this resistor, probably leading to it cracking, and meanwhile cooking the coil in there, you know, and it's right near where this connection is to nowhere. and some fiddling around with wires here from previous versions. Oh wow, that's too bad. I really think I cooked them up in there. Oh, I want to turn it on and start to smoke again. And we'll put them on with current limiting and see if I can't pick up on the heat better. Let's give that a try. Too bad I didn't have the set open like this. I could have seen exactly where the smoke's coming from. So the high temperatures on this lug here, I don't know if you can see my little laser beam. Oh. I think it's this block. Oh, it doesn't feel hot. 50. I mean, I don't know how precise this meter, I mean how focused this meter is. It can't be that focused really. 34, 28, 39. Oh, there's a part under there I didn't see before. Man, that's the cook-up right there. Pretty sure. Okay, let's before we do more damage. Well, there's a couple parts here. I'm gonna have to change this resistor because I'm gonna have to remove it anyway. Get at the part that's up in there. What would that be? What would that be? Okay, so we're back on this coil, and there's the resistor. Where's he going? He's right across that resistor, right across it. Right across it. I don't see any such. Oh boy. Well, there's a couple capacitors to make sure I'm on the right coil here. Wow. It looks like it's right across here. Give you a better view. I gotta go on to some other matters in my life after this. me some time to think a bit about it, but so here we are. Here's that cracked resistor right there. Now up kind of in behind it is, I'm sure it looks like a capacitor to me. Very hard to see. It's that dark thing in there. Right center screen now. You can just kind of see the knee of it, or a bump on it there. I think that's the guy that's heating up. So we'll have to disassemble things a little bit and get at it. So I think we're making a little bit of progress here. And that'll be it for now for the Philco 91A-221. Yeah. Thanks for watching, and I'll see you next time.